Hello, everyone, and welcome to Lecture 8. Today, we will be discussing some data management tips along with some basic statistical concepts and how you might want to start analyzing a data set. So as you can see, the associated reading is Chapter 11. I also have a piece here about how to enter data into SPSS according to Laird. And Laird does have a whole section on the website devoted to data entry and management in SPSS. So in addition to the SPSS test section, there's another section all about some recoding, creating dummy variables, all that good stuff. Okay. So let's talk about 10 data entry or management tips. As a general rule, participants should have the easiest job when it comes to entering their answers. You don't want to put any strain on them. The next easiest job should be those that are doing the data entry and then those doing the data analysis. So if you have to reverse code something, leave that to the end. Leave that for those doing the data analysis. Don't try and make people do it during data entry. Try and say, oh, when you see a 5, enter a 1. No, because their job is hard enough without adding that to it. Okay, so create a code book and include ranges. That's always a good idea. Just identifying each of the variables, where they come from, what their ranges are, etc., what missing values are, those sort of things. Use identification numbers. Always use identification numbers. That will help you vastly in terms of trying to figure out if you ever have to identify a particular case or anything like that. Take breaks during data entry. I highly recommend taking a break every 15-20 minutes. It's a very mundane task that just invites errors. Speaking of errors, another way to help avoid that is double data entry or paired data entry. With double data entry, essentially it's what it sounds like. A person is entering the data twice, and there's two ways to do it. They simply enter twice and then you compare afterwards to look for any discrepancies. Or the second time they enter it, you could have it pop up anytime there's a discrepancy and let them resolve it right then and there. I think that the first one is a slightly better choice, but either one would certainly help over not choosing to do some sort of data entry check. The other option is a paired data entry where you have people work in pairs. One is a reader, one is a typer. The reader also looks at the entry to make sure it's matching up. Use missing values rather than blanks. Now, I know that SPSS does a wonderful job of treating blanks as missing values, but the reason I say to use missing values, which is a coded number or usually a number, something that tells you it's not in there, is because when you look back at this data 3 months, 6 months from now, you want to be sure that that's not just a typo, that it really is intentional missing value. I always recommend creating new variables when reverse coding. So again, that reverse coding thing, if you have one item, if you're measuring happiness and one item says, I am very happy, with ratings of 1 to 5, with 5 being strongly agree. And the second item is, I am very sad, same set of Likert items, 1 to 5, 5 being very much agree. You're going to have to recode that second one, making 5 ones, 4s, 2s, and 3s being the same. And when you do that reverse coding process, I always recommend creating a new variable rather than keeping it as it is. Okay, that's just a good data check to make sure that you actually did recode it correctly. Long versus wide data sets. This may not be something you've come across yet, but a wide data set is the one we typically use with one row per participant, and it gets pretty wide, right? Each variable is a new column. So A long data set is what you sometimes use for repeated measures. Now, I don't think any of you are going to have to use that in this particular set of mock data. However, a long data set is when you actually have the same participant on multiple rows for each time that they participate in the study. So in other words, if you had participant 3 participate 3 times in the study, they would have 3 rows for participant 3. One for the first time they did the study, one for the second time they did the study, one for the third time they did the study. Okay. Anticipate data entry errors. Yes, data entry errors are most likely going to occur, so you might as well be prepared for them and look out for them. Look out for ranges that don't make sense. Look out for particular items that don't make sense. Look for anything that seems out of the ordinary. I'll share with you one data entry error that happened in the past, and it was a very sad one because it couldn't be fixed. In this particular case, the person was coding males and females, and this was some time ago, and they coded the males as 1 and the females as 2. Well, at some point, someone else was entering data, and they coded the males as 2 and the females as 3. I think it was a 0, 1, 2 situation. So the first one did 0 males, 1 females. The second one did 1 males, 2 females. So the ones became, you didn't know which was which, right? It was really hard to know. So if there was at least a time when someone was doing it, someone else is doing it, you might be able to tease it out. But those sort of data entry errors are exactly the kind of thing you want to avoid, and which a code book helps with. Okay. Finally, always keep an original data file. You want to always hold on to your data once you're happy with it. And then I would say an original data file, a clean data file, once it's all cleaned up and you're good to go. Keep those. You can always have a new file that you add on variables to and that sort of thing. This way, if you make a huge error that you didn't mean to make, you at least have your original. Okay. So that's the piece on data entry. And then we'll move on in just a moment. Okay, so now let's talk about the foundations of data analysis. And data analysis has important implications for conclusion validity. And data analysis has 3 main steps: the data preparation, which is part of kind of what we were sort of talking about, descriptive statistics, and inferential statistics. Okay. So conclusion validity, let's spend a little bit of time on this. The extent to which conclusions or inferences regarding relationships between the major variables in your research are warranted. Now, it's related to internal validity, but it's also independent of it. What do I mean by that? Well, internal validity is concerned with causal relationships, right? Whereas conclusion validity applies to all relationships. Okay, so what you want to know is when you make a conclusion, when you say A is associated with B, is that warranted? Is that okay to say? Okay. So this brings us back to type 1 error and type 2 error. And this is a good opportunity to recall these errors. Type 1 errors when you conclude there is a relationship when there is not, or there is a difference when there is not. It's a false positive. Type 2 error is when you conclude there's not a relationship when there is one. There is not a difference when there is one. It's a false negative. Okay, so let's talk a little bit more about type 1 error. And if you remember type 1 error, another name for it is alpha. So again, it's finding a relationship when there's not one, seeing things that are not there. The level of statistical significance, or alpha, which is often set to 0.05, meaning 5 times out of 100, you will have a false positive. Remember, alpha is equivalent with type 1 error. It's your tolerance for making a type 1 error. It's your tolerance for making a type 1 error. And then there is P, which is what you get out of your statistical output, which is the actual probability of making that type 1 error for this particular set of data. And we always want our P, our probability of making the type 1 error, to be less than what we set our alpha as, less than our tolerance of making a type 1 error. Okay, so I don't know if you've heard of phishing and the error rate problem, but basically what it is you keep phishing. You keep conducting many analyses on the same data set, treat each one as independent, and your error rate goes up. So in other words, if I look at the same data set and look at 20 different things within that data set, right? I run 20 different t-tests, let's say. Odds are that one of those, even if none of them were supposed to be significant, none of those were supposed to show a difference, one of those will, right? Because 1 out of 20, 5%. There's our alpha. Okay. So the more you fish, the more likely it is you'll find a false finding. Okay. So, and there are ways to control for that. Just using the techniques that we learned about, using an ANOVA rather than multiple T's, right, helps correct for that error rate problem. Okay, so threats to conclusion validity type 2 error, finding no relationship when there is one or missing the needle in the haystack. This can happen because you have a small effect size. And that's the ratio of signal or of good stuff to noise, or of the variability. Okay, so what are some sources of noise, the stuff that gets in our way of seeing our finding? Low reliability of measures. Okay, I know you're familiar with measures and you're familiar with the notion of how reliable they are. Poor reliability of treatment implementation. You want, if you're going to use let's say a therapeutic treatment as what you're implementing in one group versus another, you want to make sure that that treatment is being implemented in a very consistent manner. How can you do that? Maybe manualize the treatment, right? Random irrelevancies in the setting is another issue. So what if you have the treatment being conducted by multiple therapists? Well, there's a source of potential problem right there, source of noise, because every therapist is not the same. And even with a manualized treatment, maybe they're not administering it quite in the exact same way. And then you have random heterogeneity of respondents. Well, the more unique your respondents are from each other, the more different they are from each other, the more heterogeneous a sample you have, the more likely it is that you're going to have more noise. Okay, so if you really want to increase your effect size, what you want to do is have your respondents as similar as possible, to each other within a particular group. Now that may decrease your external validity, right? Because you want it to be realistic too. Okay. You can also have a weak signal due to a low strength intervention. So think of the dose here. You want to make sure you're giving people a good dose of whatever treatment you're giving them. If it was, again, a treatment, let's say a cognitive behavioral therapy, well, you probably don't want to give them the therapy once for 20 minutes, right? That would be a low dose. You want to give them an appropriate dose for what you're trying to get at. Okay. What other threats to conclusion validity are there? Well, problems that can lead to either conclusion error are violated assumptions of statistical tests. We've talked a lot about that. Sometimes when you violate the assumptions, what do? You go to a non-parametric test. Okay. Sometimes that's not so easy and it becomes a little more complicated how you want to deal with those assumptions. Sometimes we do transform, you know. And violated assumptions in qualitative research. I guess this is, while we haven't spoken a lot about qualitative research, it's interesting to note that even those in qualitative research are kind of, that they're not necessarily free to answer questions any way that they might desire, and they might feel some pressure from the experimenter. They might, just from the way the tone or the leading nature of the question, might feel they have to respond in a particular way. Okay. So how do we improve conclusion validity? Increase statistical power. You can increase the sample size, increase the level of significance, increase the alpha, right? Which we never like to do, but it is out there as an option, and increase the effect size. And while I've said in the past, this is very difficult to do, certainly you can make sure you have good implementation of the program that you're doing, use trained researchers, use maybe manualized treatment, do all those good things to try and help your effect be as strong as possible so you can see it. Okay. Data preparation. So you want to log the data in, check the data for accuracy, enter the data, transform the data, and develop a database. Okay, and we'll talk about these in turn. Logging the data. So use a computer program to log the data as it comes in, such as Excel, Access, SPSS, etc. I actually prefer personally entering data into Excel if you're doing it all by hand rather than SPSS. It's a little more forgiving with certain things, but I think either one is a good choice. And of course, if you're familiar with SAS, that's a wonderful program too. Always retain and archive the original data records. Most researchers keep original data for at least 5 to 7 years. And the IRB, of course, is going to be requiring you to store the data securely. And I would say as privately as possible, hopefully anonymously is always the goal, but definitely as privately as possible. Okay, checking the data for accuracy. Are the responses legible or readable? Are all important questions answered? Are the responses complete? And is the relevant contextual information included? For example, in addition to the, for example, date, time, place, and researcher. It should be date, time, place, and researcher. Okay. Remember that example I just gave you a little while ago about the 0, 1, 2. Well, had it been researchers working at different times, different dates, and you had the date, you could potentially piece that apart. Okay. Also, the researcher would have helped with that too. Okay. Developing a database structure. Now, the database structure is the system you use to store the data for the study so that it can be accessed in subsequent data analyses. Okay. So in other words, once you have it all in Excel, you're probably going to transfer it over to SPSS and have it laid out in a way that you can see what all the variables mean, what their ranges are, those sort of things. And that's where developing a code book comes into play, where you have your variable name, description, format, including the number, data, and text, and location. You also want to include the instrument, method of collection, the data collected, the respondent or group, and any notes. So if you're curious as to what a code book looks like, there are many examples out there, free code books you can look at. But basically you're trying to put in as much information about your data that makes sense, so that anyone looking at this in the future could decode your data. Enter the data into a spreadsheet, document, or statistical program with a unique number for each record. It's also really, really helpful and recommended to write this ID number on the paper the data was collected on, assuming you collected data on paper. And this is recommending a wide format, like we talked about before, where each case or record will be its own row, and each column represents a variable. And we did already talk about double data entry as a method of helping your data be as accurate as possible. Okay, so if you've already entered your data into Excel, of course you're not going to re-enter all the data into SPSS. There's a method of opening the data from Excel right into SPSS, and it will convert it for you. Okay. Now you have to deal with missing values, right? So you might be wondering what's a good number for a missing value. Depends on what your data looks like, but if there's no negative values in your data, you can use -9. That's a common one. If you have low values in your data, you might use 999 or 9999 as a missing value. Okay. Item reversals, we talked about reverse coding. So that's one thing you may have to deal with at this point. You probably want to get your scale and subscale totals. Name your categories, and do any other variable transformations that are appropriate at this time. Okay. Now you are ready to do some descriptive statistics. And these are the statistics that you use to describe the basic features of the data in a study. And there's three main things here: the distribution, the central tendency, and the dispersion or variability. And these are all things we've talked about in the past in terms of getting started with your data, but let's review them again in this context. The distribution, right? So you're looking at your frequencies in table and in graph format by getting the histogram. Okay, so all this can be done using the frequencies command. Now central tendency. You can actually have done this using the frequencies command with the statistics option as well, or you can do it under descriptives, I believe, as well. I think, just getting the mean is very important, of course, the average, unless, of course, you might need a median, right? If you're dealing with something that's not really distributed in a way that makes sense. So in other words, if you have a big outlier, that's where the median comes in, centermost or 50th percentile score. And the mode is often used with nominal data. Okay. And if the distribution is normal, the mean, median, and mode will essentially be all equal. Okay. But it is interesting at the beginning stage to get all three and just look across all three and see if they look very different from each other. That would be a key right there that something's up with your data. Something to look at. Dispersion, the spread of values around central tendency. Range is a good thing to get, your high score minus your low score. I also recommend getting mins and maxes because that's sometimes a little easier to look at, easier to see. And then, of course, you want to get your standard deviation, which is the variability of the scores around the average. And you know the 68, 95, 98 rule, right? 68% of scores will fall within one standard deviation of the mean, assuming normality. 95 within two standard deviations, and it says 98, but it's really closer to 99 that will fall within 3 standard deviations. So there you go. Okay. And as we talked about, the variance is the spread of scores around the mean in squared units. So in other words, how do you get the variance? If you're interested, take the standard deviation and square it. I think the standard deviation is sufficient and is usually a better, gives you a better idea of what you're dealing with. Okay, now let's talk a little bit, let's talk a little bit about correlation. So this is a single number that describes the degree of relationship between the two variables. Positive correlations always fall between 0 and 1, or I should say some number greater than 0 and 1. 0 is just neutral. And as one value increases, the other value increases. Negative correlations fall between -1 and something less than 0. And as one value increases, the other decreases. What does 0 mean? No correlation. No correlation. That's where you get that big blob of nothing. Okay. So you can test to see if a correlation happened by chance, kind of, but in other words, you can look at the correlation significance and you can construct a correlation matrix. So if you just run correlations in SPSS, it will actually give you the significance and show you how each variable is correlated with the other. Now, if you just do a correlation statement and say, I want to correlate C1, C2, C3, C4, C5, etc., then you'll get something like this, especially if you just ask for one triangle. But you can also say, well, what if you're not interested in all that? And this is just a lot of extra. What if you're just interested in C1 with C2, C3, C4, C5, C6, etc.? Okay, so you can just type the word with into your syntax and it will only give you, for example, the C1. Okay. So what are the different types of correlations out there? Well, there's the Pearson product moment correlation, used when both variables are interval or ratio. The Spearman rank order correlation, used when both variables are ordinal, right? It's going to rank them for you. Same with the Kendall. The Kendall rank order correlation, also used when both variables are ordinal. People have preferences between the Spearman and Kendall, but I would just say I slightly prefer the Spearman, but either one's really acceptable. Okay, there is some more than just the Kendall in general. It's a Kendall tau B typically that you'll see out there. And a point by serial correlation is used when one variable is continuous and one is dichotomous. So one variable tends to be interval or ratio and the other one just has 2 levels. Okay. All right. So in terms of like some final recommendations for your mock data, I would say to complete the descriptives and frequencies analyses. Okay, descriptive and frequencies analyses for your mock data. Look for any outliers, look for anything that looks funny there, look for whether you're going to use a mean or median. Is there, look for all those pieces right there. Is there a skew? Is there anything like that? Then complete correlations, just to start getting a feel for relationships among your different data pieces. And then I would recommend start looking at the assumptions for your mock data. Okay, so start looking at which analysis you'll probably be running for your mock data by looking at the assumptions. Okay, that's all I have for you for this time. So hopefully that is helpful not only for your mock data, but perhaps for dissertation data or other data in your future. And I will talk to you later. Have a good one.